So I'm going to divide these numbers in my calculator, and I'm going to write it down just for reference, but after I divide, I'm actually going to store this in my calculator so I can use the exact value here again in a minute. You never want to round in the middle of a problem, especially when you're dealing with exponential growth or decay, because that growth and decay is so rapid. So I'm going to store this as the variable k. So I'm going to hit alpha parenthesis there, stored as k, so I can use it here in a minute. Okay, so I'm going to go back to what it's asking about. How long will it take for the 10 grams to decay to 1 gram? So I'm going from this model right here, but this time I'm setting it equal to 1. I'm going to write k like it's an unknown, but remember we just calculated that value. T is what I'm really solving for. So I still solve this like normal, divide both sides by 10, so that's 0.1 is equal to e to the kt. The variable's in the exponent, so we have to write it in log form, so the natural log of 0.1 is equal to k times t. And then we divide by k, so now I can go back to my calculator using that exact value, the natural log of 0.1, make sure you close parentheses, divided by k. And we get the answer of 80,058 years, about half a year after that. So there's a reason why no one lives in Chernobyl anymore, because these radioactive isotopes take a really, really long time to decay. So just 10 grams takes 80,000 years to decay to 1 gram. Here's another example. That was a decay. Let's talk about a growth. It says an experimental population of fruit flies increases according to the law of exponential growth. So that means we can automatically go straight to our y equals ce to the kt model because it follows the law of exponential growth, ce to the kt. All right, let's look at what we're told. There were 100 flies after the second day of the experiment and 300 flies after the 4th day. Approximately how many flies were in the original population? So original population means t equals 0. So let's plug in what we know. We know 100 flies. We don't know our original amount. That's that c. E to the, we don't know k either. T is 2 days. So we have too many unknowns here. We have a c and we have k. So let's use the other part of information that we know. 300 flies, ce to the k times 4 days. So since both of these have the same unknowns, what we're looking at is either like a substitution kind of scenario. What I see is this c. So what we can do is we can isolate the c's in both equations. So divide by e to the 2k over here. So 100 over e to the 2k is equal to c. And here we divide e to the 4k. So we have 300 over e to the 4k. So since they're both equal to c, they're equal to the same value, we can set them equal to each other. So let's do that. 100 over e to the 2k is equal to 300 over e to the 4k. We've got a ratio or a fraction equal to a fraction. So how about we cross multiply? 100 e to the 4k is equal to 300 e to the 2k. We've got k's on both sides. So how about we turn around and divide by e to the 2k. So we've got 100. When you subtract things that have the same base, we subtract when we divide things that have the same base, we subtract their exponent. So 4k minus 2k is 2k. Then we turn around and divide by 100. So 300 divided by 100 is 3. Now we finally got it to the point where we can write it in log form. The natural log of 3 is equal to 2k. So divide by 2. So the natural log of 3 over 2 is our k. But that wasn't the question. The question was how many flies were in the original population. So let's set up what we've got now. We have y is equal to c e to the, we now know our k. Well, actually, let me go back to one of these models so we can find c. That'll give it to us. Either one of these would work. I'm just going to use this one since it's closer to the side over here. E to the natural log of 3 over 2 times 4 should give us our c. So let's see if that works out here. I'm going to do this in pieces since we've got a lot going on. Let's do the natural log of 3 divided by 2 first times 4. Raise e to that power. And then 300 divided by 9, look how nice and pretty that is 33.33 is equal to c. So we're talking about approximately 33 flies in the original population.